Welcome everybody. We have a talk from Wieneke and Sebastian today about running Kubernetes on the tractor. And I hope you have a lot of fun during the talk. Good luck.
Yeah, welcome everyone. Really nice to share our journey. It's a journey about our company, Aurea Imaging. We're building the TreeScout. You see it there on top of the tractor. It's a device which helps growers with farming. And we thought it's nice to give you insights in how we developed it, what we learned, how Python is a key part of this technology stack. But we first start with an introduction of ourselves.
So I'm Sebastian, I'm one of the senior engineers at Aurea Imaging. I've been working on the TreeScout for the past 3 years or so, originally from Canada, now I'm here.
Yeah, and in the middle that's me, I'm the CTO of Aurea Imaging, so responsible for all the technology, not only the TreeScout, also office automation and everything with the plug. It's not a story of me and Sebastian, it's the story of the whole team. So you see the whole team on the left-hand side, and if you look around, maybe you see some similar faces in the audience. I like this picture because we are an agriculture company, and you see here our feet are black out of mud. It was actually a team activity last September. We did some mud walking. We have kind of an international crew, so we thought it's nice to do something Dutch. But if you are a software engineer and agriculture company, you really also need to go to the field, meet our customers, and get dirty. So that's us. I know you're on a Python conference, but we're telling kind of a different story as only coding. So I thought it's good to give you a very short introduction on becoming an apple grower, because that is like the market we are active in. So become an apple grower in 5 minutes, just so you really understand our use case. So the first question for you all is, which apple is the best? They look the same, but there is really a difference. It's the middle one, yeah. Well, it's not actually not that big, but it's around between the 8 and 12 centimeters, because that are the apples you see in the supermarket, and they have the highest price. So for a grower, it really makes a difference which size apples there are on his tree. It is about, for a kilogram of Elstar apples, probably you all know that, it is a difference of 40 cents per kilogram. So that's really a lot. So all apple growers really want to have mid-sized apples. The next question then is, which tree is the best? So you see two trees with different amounts of blossoms. Yeah, the truth is somewhere in the middle. There's actually an optimum amount of blossom which gives the right size apples. Because if you have too much blossom, the tree will make much apples, but all small apples, because it's just dividing its energy over all the apples. If you have not enough blossom, it only makes very big apples, which are also not relevant. So this is more or less the market we are in, and that brings us to what our company, what is really our mission, is to unlock the potential of each and every tree. As you can imagine, an orchard, there are over 2,000 trees on 1 hectare, so there are many trees, and if you want to have the optimum tree, it's better to really able to manage the tree on tree level instead of on field level. The tree is there for 20 years, so the variety of the trees in that field grow over years. That means also that like the yield of that orchard varies over years, and you want to have a predictable orchard which gives lots of money. So there are 3 ways how to do that. They're on the slide. We focus this presentation on blossom thinning. I will explain that a little bit later how that goes. So with this mission, almost 3 years ago, the company was thinking, okay, how are we going to unlock the potential of each and every tree? We can do that by technology. So we came up with the idea of the TreeScout. This is a quick, short summary of what the TreeScout is. In the gray and white picture, you see where the TreeScout is mounted. There are cameras in the TreeScout which are looking left and right to scan all the trees. And on the left-hand side, you see it's not actually what the TreeScout does, but it's kind of visualization what we were aiming for. So while driving, you detect all characteristics of the tree, like where the tree is, where the blossoms are, and based on this insight on tree level, you can help the grower with treating each and every tree on an individual level. So we do that by the TreeScout. I mentioned it a couple of times. There are cameras in it. There's an onboard computer, this is logic. there is a specific component to integrate with the tractor's equipment, like the precision GPS system, which we use to make sure that the trees and blossoms are on the right position in the world. And we do it onboard computer. We have an onboard computer because it's used quite often in rural areas without proper internet connection. So we need to be able to process onboard and offload only the bare minimum to give the insights that is needed. I think that is for the TreeScout. And then, so this was kind of the vision. And then we thought, okay, when are we going to release it? Right? That's a fair question. And we thought blossom thinning is a use case which is really interesting for growers. The thing is, if you want to have the right side apples, you do want to make sure that every tree has the right side of apples. You can do that two ways. Manual thinning, you go to every tree, get the blossoms out, or automated, where you use a sprayer which can turn on and off based on where most of the blossom is. So we thought that's a cool use case because then growers want to buy our product. The challenge with the blossom season is that it's only there for 2 weeks. So there's kind of 2 weeks where there's blossom, and actually spraying, detecting the blossom and spraying is 3 days. So it's kind of challenging requirement for as a launching product that you say, okay, well it needs to work that 3 days. And you cannot predict when those days are because nature is just there. But anyway, we came up with this would be more or less the ideal process. So the grower grows through his orchard, scans all his trees. Then we make a map. It's nice. Those kind of maps is geodata, which was 2 talks before was explained very clearly. Then the grower used that map to make a special format which can be imported in the sprayer. So the grower says, okay, I want to spray every tree with more than 100 blossom clusters. He makes a map, loads it in the sprayer, and then drives with the sprayer through his orchard, and it goes on and on. So nice vision, still very ambitious to build at once right for those 2 days in the year. But nevertheless, we tried it, and you understand that making this product a success, you first need to know where the trees are. So that is the first step of our product is right tree positions. And then when you know where the trees is, then the next time you go to the orchard, you can scan blossom and for the characteristics. So we went into the first season of 2023. The good thing was, well, we had the hardware available, we could put it on the tractor, and we were looking, we were trying to get results, but they were not looking as we want to. So the first picture is a GPS track. So we were integrating with the GPS, we were processing it on board. What you see, you should expect that it is a straight line, because like the tractor is driving between the rows. But it looks like a drunk driver, right? And I called the driver because I know him, it's our field engineer. I said, what did you do? And he said, no, it's just going, going straight. But the big question was, why? We really didn't have any clue. And the other picture, like the white spots, that is where the trees actually were. And the red spots was what we were detecting. So the good news was we were detecting trees, but we're not in the right spot, right? You see kind of a pattern, but it didn't make sense. So the first season, well, we learned a lot, but the product was not usable at all because the time between driving the data and actually having insight was a month. Well, that's not 2 days. We found issues and we had no clue how to solve them. So my software engineers were kind of in panic mode because I was sending them into the mud. They were sitting next to the device thinking, well, no clue how to solve it. So that was more or less when we thought we were start thinking how to solve it. And there Sebastian did a great job, so he should explain that himself.
All right, so this is about where I come into the project. So I came onto the TreeScout project basically right after this. So after the blossom season of 2023, the team had kind of a reckoning. We had to decide, where do we go from here? How do we actually take this and turn it into something that works? But to start with that, I'm going to go over quickly some of the challenges that we face when building something like this for an agricultural environment, for the farm on a tractor. So yes, the first part is pretty obvious. You're building for a vehicle, limited power available, and it's a mobile platform. You can't exactly have a network cable trailing off the back of the tractor, and it's on a farm. Not much connectivity to be had. If you're lucky, you've got 4G. Most of the time, you're not lucky. So all the processing, or as much as possible, has to be done on board, and you upload only the bare minimum to the cloud. You also can't rely on an always-on connection for instructions from the cloud either. Upload only architecture. Same kind of idea. We're in a there's already standards for a lot of the stuff surrounding agriculture, most notably GPS. And the GPS standards are actually developed by the maritime industry, because they're the ones who first realized, hey, we need high-precision GPS for positioning, I think it was oil rigs. So if you're doing oil rigs, you need high-precision positioning to within about 2 centimeters. Precision agriculture works the same way. Typical GPS is only good to within about 1 or 2 meters. But when your trees are 50 centimeters apart, and you're only good to within 2 meters, you're suddenly spraying 4 trees over. That's not good. And finally, we're building off the shelf. We're not a hardware company. We're ultimately a software company. The hardware is there because we need it to be there. So we're mostly building using off-the-shelf parts, but that means lots of third-party drivers, third-party hardware, vendor integration. And finally, yes, agriculture. It's a global business. Those of you who were at the talk about field boundaries an hour ago, there's people growing fruit all over the world. Big fruit growing regions here in the Netherlands, in Germany, in New Zealand, in the US, in Canada, everywhere you go. So it has to work around the globe. And this comes with its own set of challenges, both some obvious if you're doing machine vision stuff, some not so obvious, and which we've encountered, especially as we've started to expand our fleets across Europe and the world. So then, with that in mind, let's take a step back to 2023. This is what the system architecture looked like almost exactly 2 years ago. Basically, you had a, geez, that's bright. You had basically a single Python monolith repository broken up into about 5 separate services communicating using multiprocessing. Now, who here has done anything with Python's multiprocessing library? Raise your hands. So, you guys know what the pain points are. One of the biggest challenges we faced during the 2023 season was actually that pieces of the software would crash. Kind of obvious, I guess. So we had a component in the middle that would detect this and restart them, which is great. Except it's multiprocessing. Default remediation mode, Unix pipes. And that's what we were using. So even when the services came back online, they still couldn't actually reestablish their communication with the rest of the system. So even though we had this watchdog, the system was still broken and would stay broken until the whole thing was rebooted. Beyond that, we had some quality issues. A couple of the services were responsible for far too much of the system. The detection service in particular was responsible for camera interfacing, GPS interfacing, machine learning, the machine vision part, positioning, and a couple other bits as well. And this actually resulted in performance issues. It was some of this stuff was running separate threads, but because it's Python, the global interpreter lock, you ended up with stuff not running at the right time, weird thread pileups. You would suddenly have the frame rate would do this sort of weird sawtooth thing where threads started piling up until it hit a tipping point, and then it came back to normal performance, and so on. So with all of that in mind, we then had to make a choice. And the choice was essentially this. In about the summer of 2023, after looking at all the problems we were facing, we took a long, hard look at our core software architecture. And the two options we looked at, one fairly conventional, one, at least at the time, fairly radical. So who here does embedded vehicle, ROS kind of stuff? Okay, a couple people. We looked at that, but then we realized, hey, we're a Kubernetes shop. We already have a wealth of expertise in running or building and running distributed systems using Kubernetes. And ultimately, that's what tipped the balance. We estimated it would take about 18 months to 2 years to bring ourselves back to a working product using ROS. We picked Kubernetes, or K3S, which is a lightweight Kubernetes distribution designed specifically for edge applications. And we were actually able to bring the system back to a working state after total refactor within about 4 months. Quickly enough that we were actually able to resume testing within the same growing season. And that, after 2 years, leads us to this. So today, we have a single node Kubernetes cluster sitting on top of a tractor running an 8-service architecture. Each service has between 1 to 4 separate components running in their own Docker containers, and there's a much better diffusion of responsibilities. They all communicate using an event bus, rather than do in this case, because that's what we do best. And the result is that we've eliminated the performance problems related to too many responsibilities. There's no more multi-threading, no more multi-processing. Kubernetes takes care of the system resilience stuff, which means we're able to access all of that wealth of Kubernetes ecosystem tooling. I'm not sure how many people either do like in the United States do Kubernetes, but there's a huge ecosystem out there of tooling for system resilience, scalability, automatic deployments, everything you could ever possibly want out of your DevOps infrastructure. And what that's really enabled us to do is do what the guy in the hacking cars talk said is impossible. Deliver updates to automotive hardware on the fly, day or night, 24/7, 365. And so today, our stack looks like this on both the tractor and the cloud side. So yeah, it's all Python based from top to bottom. We don't actually have any native components that we create ourselves. Some of our vendors include some native components, but we don't create any native components ourselves. It's all pure Python. Of course, NVIDIA stack for machine vision, machine learning, Kubernetes on both the cloud and the edge. We actually use UV for everything, which becomes important a bit later. And Amazon for edge-to-cloud communication. And of course, on the cloud side, fast API, because let's face it, if you're a modern Python company, what else are you doing? And what has all of that brought us? I'm going to hand this over back to Wieneke.
Yeah, so we are now 2 blossom seasons past, so I brought the same metrics, and in 2024 we run with the same amount of devices, because yeah, the first year it didn't work out, so we thought, well, let's not scale yet, but first make sure that it works. And it worked out pretty well, so we deployed it at 8 customers. They were happily driving, Blossom maps were coming out, they were processed in time, and even the time to fix incidents, I think for me that was really important, was pretty quickly. So of course we make mistakes. It's still a complex product and we still can only run it once a year in the end in real life. So that's not a problem. As long as we can fix the incident quickly, I'm more than happy. The thing that we didn't do in 2024 was bringing in the operations team. It was still like, yeah, kind of not really a rush, but the Blossom season came of course too quickly, so we didn't have proper tooling to support. So the development team was supporting. I had 8 software engineers, 8 devices. It was a perfect match. Well, after that success, we were brave enough to scale even further. So last month, around 40 devices were driving. Pretty cool. We have brought in an operations team to support. The only thing is, last year the processing speed of one Blossom map was around 1 hour. That increased to 24 hours. It was still within our specifications, but we were overwhelmed with all the data. We tested it, that it was within 24 hours, but growers were already used to 1 hour. So we kind of, that's a challenge for next year to even improve that. And I thought it's also nice to bring a small video about what the farm is actually doing. So you see here a tractor with a 3-row sprayer, and you see he put a light on top of it, so you see when it's spraying and not. You see that with the trees with much blossom in it, the sprayer goes on, and when there's no blossom, it goes off. So this is based on our maps, and this is actually made by one of our customers who was so happy with the product that he made this video for us and shared it. Our WhatsApp of our sales team is full of videos of growers driving, see, you look, it works. How nice. So that's really nice feedback. They're really proud customers if they adopt such a new technology.
Of course, not everything goes according to plan. So last year, of course, not everything goes according to plan. Last year, the device worked, mostly. One of our developers, who shall remain nameless except I'm wearing his underwear, made a bit of an oopsie. I managed to switch around one of the checks in our camera handling code that caused every single image the camera generated to come in upside down. Let me give you a hint. In agriculture, the tree root goes on the bottom. Thankfully, though, because we have this Kubernetes Docker-based architecture, we were able to find the bug, fix the bug, and roll it out to the affected customer site within about 4 hours. The customer actually redrove his field later that afternoon and got a perfect blossom map out, despite the tight timelines. So, with all of that, what did we learn from all of this? Because it's been a hell of a journey. Well, rule number one, play to your team's strengths. We're not an automotive company, we're not an embedded device company, historically we're not even an edge company. Our background is in GIS analytics, agriculture, and yes, some Kubernetes. So we stuck with that. We stuck with what we knew, and because this is 2025 and we have all of this really magical tooling available, we were actually able to make that fit in what would otherwise be an extremely unconventional environment for this kind of stacking approach. And the result of that is, yes, we have to think about the hardware, we have to deal with the hardware interfacing, but that's not the primary problem we solve. We're able to dedicate most of our time to actually building and refining the applications, building and refining the stuff that really adds value for the grower, rather than messing around with the internals of the automotive side or hardware interfacing. This one I'm sure comes as no surprise to the Python folks in the room. Anyone who's built web servers in Python knows this one. But yeah, the reason the 2025 Blossom season had such a bottleneck in map processing was effectively this. Some of our processing pipeline has CPU-based bottlenecks where it's retrieving data from a fast API server. Fast API server has to do some blocking CPU operations, and I'm sure you guys know what happens next. If we try to run too many map generation operations at once, the fast API server bogs down, and the map generations fail, or users can't get data out. This is something we're still working on. The solution is probably going to be we pre-generate more of the CPU-intensive stuff asynchronously, so that we can just serve it up from a backing data store like a bucket of some kind. Now, who here has worked who here does not just machine vision but works in the Jetson stack? Okay, a couple people. So you guys know what I'm talking about. If you guys think NVIDIA dependencies on a desktop are painful, that's got nothing on the Jetson stack. The Jetson stack imposes, because NVIDIA publishes not only libraries for ARM, because the Jetson is an ARM device, they also publish full OS images and full Docker images that you effectively have to use if you want to use their stuff on ARM. But that imposes a whole bunch of really, really painful constraints. If you're on anything but even the latest version of NVIDIA's OS image and Docker image for that OS image, for the Jetson device, is on Python 3.10. If you're on one version behind, which only went end of life in what, October? You're stuck on Python 3.8. And it takes some work to get out of that trap, but you can get out of that trap. The biggest thing we've done to actually get out of that is just compile TensorRT and some of NVIDIA's other libraries from source. It takes time to get it going. You need the hardware to compile against, because you can't just compile it against a generic ARM device. You have to compile it actually against the specific Jetson target. But you can make it work. And what we do now is actually we target Python 3.12 for most of our stuff right now. For Python 3.12, we compile versions of TensorRT, ONNX runtime, and a couple other things, and publish them as wheels on our internal PyPI. The result of this is we're actually able to avoid that trap entirely. There's other bits of the trap that we are still stuck in that we're currently actively working on getting out of. For instance, if you want to roll out a new version of NVIDIA's OS, you've got to go out and reinstall it on every single one of your devices. Which, if they're in farms scattered across half the world, well, you're kind of stuck. So we're actually still on that previous OS version, one with Python 3.8. Our Docker image runs Python 3.12, but there's a lot of features of the Jetson ecosystem that we can't access because we don't have that new OS version. And we're currently working on ways to automate or sort of make it possible to update the OS remotely using more Kubernetes tooling, containerized operating systems, which I'll get into in a moment. And yeah, finally, location. I said before, it's a global business. What works in the Netherlands may not work in the UK. Yeah. In the UK, in South Africa, in Germany, all over the world. Some of this stuff's obvious. If you've done any machine learning, you know how this goes. Or machine vision. You know how this goes. Your model breaks down because the soil color is different, or something like that. But more recently, we actually had a fun one with the Kubernetes part of our stack, where devices in the UK and Germany would actually pick up a couple of IP addresses on their 4G network adapter before settling on one. Something the local telecoms do, I guess. Problem is, K3S would grab the first one it got and bind to that. The effect of that was that K3S actually became inaccessible from within the cluster, which would cause some of our software to stop working. The fix there was just use a dummy network with a static IP address, but it took us quite a while to actually get to the bottom of that and roll a fix, because how do you diagnose a problem that's happening, that's site-specific, not even device-specific, not fleet-wide, but specific to individual customer sites? Yeah. So, with all of that, where do we go from here? Yeah, so next step, what we're working on really right now, starting like a week from now, the next step of over-the-air updates. The car guy said you can't do over-the-air updates to hardware. We beg to differ. Using tools from the Kubernetes stack and the Docker stack, like especially Kairos, which allows in-place OS updates based on AV partitions, like Argo, which enables fleet-wide rollouts to even hundreds of Kubernetes clusters worldwide. By the end of this year, we're planning to have the ability to actually fully automatically update our entire fleet remotely, without manual intervention or shelving into individual devices. And asynchronously, meaning that the device can update on its own schedule. We're also working on changing the camera placement. Some farmers grow taller trees, some farmers grow shorter trees, some farmers want the camera mounted on the front bumper, some want it mounted up high. Right now we've got one set of fixed camera mounts and that's it. We're still working on making that part work. Big data analytics. Each device generates, 80 million data points per blossom season, something like that, in 3 days. Multiply that by a fleet size of 40, multiply that by next year's fleet size of almost 100, and you get the idea. We're an 8-man dev team. And yet we're suddenly pushing maybe not hyperscale, but certainly megascale. So we're really working on how do we actually make those geoanalytics scale with it, especially for not just a bigger fleet size, but also bigger individual customers. Fields in the Netherlands are a couple of hectares. In the US, you've got farms that are hundreds and hundreds and hundreds of hectares. And the analytics have to work the same way there as they do here. And then, finally, increasing the fleet size. I kind of alluded to this before. We're having some concurrent processing issues. We need to make that work in time for the fleet size to grow to 3 digits, even 4 digits and beyond, as we spread these devices worldwide. Because, yes, the end goal is we've got one of these on every apple orchard, every pear orchard, every citrus orchard from here to the South Pole. And that about wraps it up. We've got still a couple minutes for questions, especially since it's the last talk of the day.